Good morning, everyone, and I want to just thank Ceres and RECCS for hosting this here at this auditorium. I am Cece Weaver, or Cecilia. I'm studying microplastics in the Beaufort Gyre, and I like to thank my mentors, Alex, Lingwei, and Jed, for helping me out throughout this process. So we'll start in the Arctic Ocean, the North Pole, that area. What we considered pristine before is no longer pristine. We're showing significant concentrations of microplastics, and this can be caused by multiple source pathways. But microplastics in general are plastic particles up to a mean of 5 millimeters of diameter. And what are they specifically? Where are they coming from? So what people typically think is usually secondary microplastics. So anything that's plastic pollution in the ocean. Over time, fragments of fishing, bags, bottles, any of those types, those are typically going to be, over time, microplastics. And then what I think is really important is the primary microplastics. So these are made small on purpose. Think of your everyday skincare, so exfoliants, moisturizers. They could have microplastics in them, eventually entering into the ocean. And of course, this gives us an environmental impact. So if it's ingested by marine life, it enters into the food chain, into us, and that can carry toxic chemicals or pathogens. So we don't want that happening. So our focus in this whole research is investigating how these tiny plastic particles are transported and retained within the Arctic. And we're specifically focusing on two main types, basically by buoyancy. So positively buoyant are polyethylene and polypropylene. These have the less density than ocean water, so they're going to rise to the surface. And then our neutrally buoyant microplastics, so our aged microfibers. So they're same density as the ocean water, and they usually rise into different types of depths in the ocean. So what is the Beaufort Gyre? How does this come into play? So the Beaufort Gyre is a 600-mile diameter wide clockwise circulation pattern within the Arctic Ocean. The circulation causes collection of excess freshwater and sea ice, where sea ice can remain in the Arctic for years. And our main research question asks, how does the Beaufort Gyre influence microplastic accumulation? And does it act as a microplastic retention zone, or what we like to call a plastic garbage patch? So my methodology consists of a supercomputer. It uses the Community Earth System models ran by UCAR. It includes tiny tracer particles that act like plastic, and it helps us see where plastic goes in ocean and the sea ice over time. So first the simulation uses multiple runs, but we're going to keep it simple and use 2 runs. We use a baseline run where microplastics are taken up into the sea ice but are only released when the ice fully melts or melts from the bottom. And then microplastics are traced based on where they came from. So think of your major oceans like Pacific, Atlantic, and the Indian Oceans. And then we analyzed sea surface height, the elevation of the ocean, and then combined it with microplastic concentration to see if it actually accumulates. So what we first have here is the sea surface height on the farther left, and then we have our microplastic concentration with the model year of 2017. We do see that the sea surface height shows us a bowl-like shape, the Beaufort Gyre. And then we do see that positively buoyant ones on the farther right tend to drift into the gyre's edge and center. And then we do see that neutrally buoyants end up just being throughout the Arctic, and this is through depth integrated, so 0 to 5,000 meters. And so we kind of see them that they are just accumulating all over. Then I analyzed sea surface height variability just to check what is actually a strong gyre versus a weak one. And we do see that the local mean and max shows the gyre's sea surface height variability. And then we also noticed that a high sea surface height gives us a strong gyre. So you will clearly see that on a local maxima in 1983. You'll see that there is way more orange there. And then we see a decline in 1998. And then the one we saw before, which is 2017, one of our current models has, you kind of see it's around that average time. So a weaker gyre is when you see that decline on there. Now, how is it getting inside the Arctic, specifically in the gyre? So we do look at microplastic source distribution. So we're looking mostly at the Pacific Ocean. It's being the dominant microplastic contributor. We're also knowing that, which is quite surprising to me, is that the Atlantic role is actually increased, which takes a larger portion in the gyre. And then at the bottom there, you're seeing that microplastics in the Arctic show an increasing trend. So regardless of what we're doing, it's still increasing within the Arctic, and it's still polluting our ocean. Then we combine it all together, and we do see and notice that with the sea surface height index throughout 1970 to 2017, we are seeing detrending with it, because we do know microplastics are accumulating, so that's going to be linear. But that positively buoyant microplastics seem to respond way more strongly, and surprisingly the Atlantics much more, as their correlation coefficients are quite higher. And then the positively buoyant plastics versus the neutrally ones, which is to be expected with sea surface height. The positively buoyants are responding more strongly, and like I said, the neutrally buoyant ones are more mid-depth level, so that kind of makes sense to us. So our discussion really here is that positively buoyant plastics in the Beaufort Gyre are really the key point here. They respond more strongly to sea surface height changes. They're also the highest concentrated microplastic in the gyre, and most are coming from the Pacific source. And I think that's largely due to location. But to conclude, the Beaufort Gyre is picky because it affects how microplastics build up, and it depends on the type of microplastic and exactly where they're coming from. So unfortunately, the model captured general trends, but it does not fully reflect the dynamics of Beaufort Gyre as a circulation system. It was quite hard for me to understand the different types of circulation phases. We tried to do that. The sea surface time series that we first had did not resemble the Arctic Ocean Oscillation Index, and that's largely to do with our Japanese reanalysis we have in our model. So that was a little bit of a limitation. So we'll probably try to explore the circulation dynamics, whether it goes clockwise or counterclockwise, or just has anomalies in detail, and then trace more microplastic pathways to improve residence and inflow timing of the gyre, specifically maybe focus on the Bering Strait, where most of those Pacific microplastics are coming from. And then I would like to acknowledge my mentors again, my Community College of Denver, RECCS, Madison, Alicia, and Carla, for helping me out throughout this process. And I do have additional figures, and we're excited, and I will be taking any questions.